Let's go through this real quick, guys. Then we can cover one more chapter, and then preferably next week onwards, we'll be doing exercises to prepare you guys for the exam, which is on the second week of June, right? Or the first week of June.
Second week, something big.
Okay, all right. Anyways, let's go through the answers together real quick, guys.
How much is the new physics supposed to cost? Or will I have to wait until the other method?
No, as soon as you are. So basically for this books, right, well, will be done at the end, which is going to be the sound chapter, right, which is like 30 more pages. Once you're done with that, I'll automatically give you guys the new book before we move on to the new chapter in the new book.
Should I hold on to the third buy?
You should definitely hold on to it. Okay, anyways. Yeah, let's go through the answers real quick, guys. Obviously, what happens to the frequency, guys? It stays the same, there's definitely no changes, and the speed of the wave will decrease, right? Then the wavelength obviously will also decrease. This is once again with tandem with the V equals to F lambda formula, guys. Remember this, like if you see this, this should be 3 marks to you guys. Do not lose marks to these. It's like as free as you can get already. Then this one is just a simple calculation. It's basically the V equals to F lambda formula. F would have been equals to V over F. What? V over lambda. Right. And in this case here, it will be 0.12 divided by 0.08, which is obviously going to be 1.5 hertz. Make sure you write your units. Everyone. Yeah. And this one here. Okay, this is the typical refraction question, right? Once again, deep going into shallow, will the speed be faster or slower? It's obviously going to be slower. So what happens is, by right, it was one straight line down, right? I mean, imagine this one straight line down. So what happens is the speed of the wave lag behind, right? So once you have this, guys, make sure that when you draw this, the first 2 lines are parallel to each other, yeah? Because if you don't draw the first 2 lines parallel to each other, right, it's very hard for you guys to draw the third line. I mean, I can't draw it like this, right, because I'm drawing the damn mouse, but you guys should get the idea. And the wavelength should obviously be the same for each and every one of it, and it should have the wavelength should have decreased compared to the wavelength here, guys. This is very important, yeah. Right, very important. Okay. Yeah. I think we kind of went through this last week, right? It was weird. Anyways, this one also, if you lose marks, it's literally GG town already. It's supposed to be amplitude DE, right? And the wavelength. How many of you guys wrote the wavelength as AC, by the way? So that I can so that I can come over and beat you. No one is raising that. It's supposed to be CF, guys, because I've said this multiple times. It's as soon as it starts repeating itself, yeah, right? Once again, it's 3 marks. You should not lose this. And then this one here is just basically drawing a louder wave, right? Louder wave. What was responsible for the loudness again? Amplitude, right? So from here, we should know that we should draw a larger amplitude wave, right? How come so many of you guys didn't draw it? You're supposed to draw a louder amplitude wave, but with the same wavelength, because the frequency remain unchanged, guys. So wherever it hits the equilibrium, you're supposed to hit it back again. So it looks something like this, right? Yeah, it's correct. Yeah. Everyone, make sure you do it. Bro, he drew this. He literally didn't draw any of this, and he just drew this, and he's looking at me like, yeah, right. Yeah, right. Bro, draw all the way here, all these. Not just that one pathetic lump here, you know. Okay, then anyways, this one wavelength here, once again, is a very straightforward one. Once again, V equals to F lambda. Lambda would have been V over F in this case here, and it will be 500 divided by 200, which is 7.5. Make sure you write your units. What's the units? What unit is that? No, it's supposed to be in meters, bro. Length should be in meters. Why? Dude, lambda is the symbol. This is the units. Oh, meters, guys. 7.5 meters for those who do not write the units. Yeah. Yes. Right. And obviously the frequency of the sound, once again, the decreases. Do you write decrease? This is no excuse, guys. Like, you lose marks for this frequency one is absolutely unacceptable, guys. It should definitely be the same, right? And then the speed will. Yeah, seawater into air is just basically going to be, yeah, liquid into air. Huh? Wait, you're talking about frequency or what? Oh, because frequency will never ever change. This is going to be a form of refraction one. Just as. Yes, as I mentioned again, reflection, refraction, and diffraction, the frequency will not change. The frequency will change when the wavelength changes. If the wavelength changes. When will the frequency change? That's a very good question. Okay, so let's imagine, right? If we think about that question, it's basically going to be related to the V equals to F lambda formula, right? If assuming the speed of something was the same, a decrease in wavelength would have increased the frequency. Oh, you get what I mean? Like, for example, if we talk about electromagnetic waves, you know, like electromagnetic waves, radio waves and gamma waves, they have different wavelengths, right? This is a radio wave and this is gamma wave, which is something you will learn later on as well, right? It will be something you learn later on as well. If the fact is that all electromagnetic waves, they all travel at the speed of light, which is 3 × 10⁸ meters per second. So this is also like 3 × 10⁸ meters per second here, right? Now, obviously, because there is a difference in the wavelength here, I know for a fact that the frequency will change in this scenario. It is because, once again, with accordance to the V equals to F lambda formula, what happens is if the speed is the same, right? If the speed is the same, what happens is a decrease in wavelength, like for example, here into here, would have increased in frequency. So means to say the frequency here is actually higher compared to the frequency here. In this scenario, obviously the frequency will change out because in this scenario, the speed would have been the same. You understand how?
Yeah.
Did I lose you halfway through your question? Right. So in this scenario here, what happens is the speed of sound would have definitely changed. And my question is, C going into air, would it increase speed or would it decrease speed? Why? Why would it decrease in terms of speed? What?
Yeah.
Guys, I think I kind of mentioned this last week, right? You know how sound is traveled, right? Like basically the reason why you can hear me right now is because it's the vibration of the air molecules. That's why you can't hear in outer space, right? But today, if you think about air, which has relatively further molecules versus liquid, which has relatively closer molecules, versus solid, which have molecules that are literally touching each other, right? Right? Then obviously you can tell that here, if you imagine it in terms of the vibration, this one is vibrating, pass energy, vibrating, pass energy, vibrating, pass energy. This one is vibrate, pass, vibrate, pass, vibrate, pass, vibrate, pass. This is like pass all the way already. That is the reason why speed of sound in air is always the slowest, whereas the speed of sound in solid is actually the fastest. Later on in the final chapter of the wave, right, you even need to remember that this number, the speed of sound is somewhere around 330 meters per second. Speed of sound in liquid is somewhere around 1,500 meters per second, and speed of sound in solid is somewhere around 3,000 meters per second here. One very easy way to remember this is from here to here is a multiplication of 5, and from here to here is somewhere around a multiplication of 10. These numbers are important because a lot of times the question base your understanding on these numbers here, right? So yeah, later on in the final chapter of wave, we'll be talking about sound, which is going to be about this. Okay, but for now, you don't need to remember these numbers. But you do need to remember this number though, like this is a rough estimate. Speed of sound is somewhere around 330 meters per second. Okay, everyone. And thus, because of that, from seawater, which is liquid, into air, which is gas, obviously the speed of sound decreased here. If the speed becomes low, yeah. Okay. Yeah. Okay. Next. Then process that takes place in boundary. Obviously, this one here, shallow into deep, is going to be refraction, guys. Fraction, right? And the one thing that doesn't change is obviously the frequency. You want a building, Charles? Okay. Anyways, this one here is basically going to be, if you see these like barriers and gaps, this is for sure going to be a form of diffraction already, guys. Right. And I ask you, how does compression differ from rarefaction here? You're always supposed to answer this in terms of their pressure, guys. Compression is a region of high pressure, thus molecules are close together. Or you could say rarefaction is a region of low pressure, thus molecules are close. I think if you just wrote either one, it's fine, because it's only one mark for this one. But I would have written two. Yeah. And moving on, this next part here, the speed of sound is somewhere around 340 meters per second. The frequency is this amount, determine the wavelength. Obviously, once again, you're supposed to write V equals F lambda. Lambda would have been V over F, right? In this case here, would have been 340 divided by 850, which is supposed to give you 0.4. Once again, do not forget to write your units, which is in meters, guys. And then it wants you to find that the time elapsed before compression A reaches the barrier here. Now from here, you need to understand that this is compression to rarefaction, right? It's always going to be compression to compression is considered one wavelength, right? In other words, here to here is another 0.4, and here to here is supposed to be 0.2, guys, right? Making it a total of 1 meters here, right? Then if they ask you for the time elapsed, you're just supposed to use the simple formula: speed equals to distance over time. Time would have been distance over speed. In this case here would have been 1 meter divided by 340 meters per second, which is going to give you a damn small number. What's the number? 4 times 10 to the power of negative 3. What's the units? Seconds. Okay. Then finally, oh no, not finally, draw the shape and position of the compression B and C as compression A reaches the barrier. So you're actually only expected to draw 2 diffractions, guys. You're expected to draw 2 diffractions, and I've mentioned this in class before. I'll say this again, guys. When you draw the first one, make sure the first thing you want to know is whether the diffraction is more or less, right? In this case, obviously the wavelength is larger than the gap, right? When the wavelength is larger than the gap, obviously diffraction occurs the most, which is the proper Wi-Fi signal one, right? So what you want to do is you want to start at the gap here, right? This is a criteria, right? Now the second thing is, once you draw the second wave, you must roughly from the eye level seem as though that the wavelength here and the wavelength here is the same, guys. It doesn't have to be exact, but it looks as though the same, then is good enough already, right? It must look as though they have the same wavelength, like for your one there, it looks a bit too small, right? This is definitely too small. This is wrong. This one looks too small, so the wavelength is need to see it. That's too close, Slide off a little bit further away. This one slide off a little bit further away from. You want it to straight in the barrier, which should be like a little bit towards the right of the barrier. Think of the gap. So the barrier, give it a little space, right? And draw a second. A bit small, wavelength. You know, like this here, and this one to this one to be the same, and this one to the next one. Come on. This wavelength here should be this distance here. Because accretion doesn't change the wavelength, guys. And it is written down in mark scheme. If your wavelength is too small, you will lose your marks for this drawing. Yeah, it will take some time to get used to. Yeah, that looks a little bit. Don't draw all the way here. It's not going to be here. Like you wouldn't extract this. Only going to be some gap here. Because if you think about it, it spreads out. Hey guys, pay attention because it spreads like this. So don't extend your line until like it touches this barrier here. It's supposed to like kind of go in this direction downwards, guys. It's supposed to go downwards. So don't extend it all the way until here. Some of you guys, I can see you guys extending all the way. Oh yeah, don't extend it all the way. You know what I mean? Like it's supposed to, if you imagine how it moves, it's supposed to go something like this. It's spreading outwards, so don't do a full U. Yeah, that's good enough already. I'm talking about erase the tail there. Give it some space there. You know no. Let's erase this bit. Okay. State how the sound in air compares to the speed of state how the sound in water compares with the speed of sound in air. Obviously, the speed of sound in water is faster, guys. You're supposed to say speed of sound in water is faster. Or somewhere along these lines, just say that it's faster, higher, or whatever. Blah blah blah. Okay.
Yes.
I like how when you flip the page, you can lift it all the way up. Become like one round here. Huh? What? Okay, anyways, last page here, guys, before we move on to the next chapter here. A dolphin produces blah 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 blah. This is obviously going to be a frequency. What is meant by rarefaction, guys? Once again, you're supposed to say region of low pressure. Like use. Shit, what further apart? Right. Then after that, A and B, A to B is 0.76. A to B is 0.76. In between, there's 1 wavelength, 2 wavelength, 3 wavelength, and 4 wavelengths, right? So you're actually supposed to find first and foremost that the wavelength is going to be 0.76 divided by 4, which is going to give you 0.19 meters, right? 4. Right, that's 4, right? 1, 2, 3, 4, 1 wavelength, second wavelength, third wavelength, fourth wavelength, right? What do you write? Do you write 5? This is not 1 wavelength, this is a wavefront. Okay, so you're supposed to get 0.19. Then after that, the time taken for the rarefaction A to reach B is now positioned. So once again, you're looking for time. You're supposed to use the speed equals to distance over time formula. And time would have been distance over speed. The distance would have been 0.76, but you don't know the speed, right? So what you have to do is, in order to find the speed, you have to use the V equals to F lambda formula once again, which in this case here would have been the 7,800. The 7,800 multiplied by a wavelength of 0.19, right? With this, you would have gotten some speed. How much is the speed? What? 1,482 meters per second. So basically, you substitute this into this, right? 1,482, and you have gotten a time, which is once again a damn small weird number. Somewhere around 0.5, I assume. 0.0005. And you get 5, you'll get somewhere around 5.1 times 10 to the power of -4 seconds. Do you get this one correct? Very good. Okay, and once again, state what happens to the frequency. Nothing. But the wavelength, since I have a greater speed, is going to definitely have increased, right? Then after that, they ask you to sketch the position of the wood of the 3 incomplete rarefactions. This one here is going from water into wood. right? So is the speed going to be fast? You wrote faster also, right? You wrote increased speed, right? This here is a decrease in speed. Hey, what? Didn't I kind of talk about this last week also? Here the speed is slower, right? Here the speed is faster, right? So once again, I should know that since there is a speed increase in speed, it should not lag behind, right? The waves, it should lead forward, right? And just make sure your first two are parallel, then you can draw the third one parallel to all the rest of it already. But
How do you know what angle the line?
oh, you don't know, but you don't have to know. You just need to draw like the first two only. I mean, even if you drew something like this, it's acceptable also. The only criteria is that they must be the same. They must be parallel to each other only. The wavefronts after diffraction should be parallel to each other. That's all. That's why you always draw with a pencil and reporting. Do you get it correct? The drawing? Okay, everyone? I think quite a straightforward question. Yeah. Okay, and we're done. Yay. I don't think I can finish this today, right? But we'll definitely finish it next week. And then hope and pray that the lens will come out. By the way, for those who don't know what the lens are, if you see this in your school, let me know. Like this thing here. If you did see this in your school, let me know. Because there's a lot of drawing involved in this one.
What do you mean by uh-oh?
What do you mean? You mean a school teacher taught you this already? Oh, okay. That's good. Okay, but if you see this, let me know. Because there's actually damn a lot of drawing for this chapter. Hopefully it's not. Hopefully it ends here, which is supposed to be at the critical angle and total internal reflection. You guys learned this in school already? But yeah, we assume right now that it's going to be until this chapter for this exam. So we're going to learn it right now. This chapter also, there's going to be a lot of drawing involved, guys. So usually the structure of the question will be something like, okay, right now this is you standing in front of the mirror with one hand raised above your head. A super simplified one, right? And then this is a mirror here. Okay, let's say this is a mirror. Okay, and then they'll ask you the first question they'll ask you is, where do you think the image is going to be? And for some godforsaken reason, I don't know why, some students, they will sometimes tell me the image is going to be here. Sometimes they'll tell me that the image is going to be here. Like clearly something is wrong with their heads or something. Like, yes, that's why the head is missing here. I just want you to remember this very important fact. Whenever you stand in front of a mirror, your image will be literally exactly opposite of you. Right? It should be literally exactly opposite of you. And it should seem as though that you guys are equal distance away from the mirror, which is literally how you see yourself every day, right? I mean, I don't know why. Some students will draw it here, some students I'll beat you, by the way, if I see this. I will definitely beat you. Oh, am I saying play? Okay. So first things first is usually they won't ask you just something like this, right? They'll make it a little bit harder. So they say like, okay, guys, with reference to this point of interest here, right, which is the tip of your fingers or your hand or your whole arm. Yeah. Oh. Ew. No, but anyways, they'll ask you to draw the light ray diagrams, guys. If they ask you to draw the light ray diagrams, usually they'll ask you to draw two. Okay. If you think about it in a super 1D mode, right, which is never the case, they will never ask you to draw 1D, or they ask you to draw 2D. If you think about it, just 1D mode, right, what's happening is the light rays will enter the mirror, it will actually bounce back, but it seems as though the light ray entered all the way into the mirror here, and wherever the light ray stops, that is where your like anti-Hitler guy is right. It's gonna be this one here, right? Right, but what do you say? Yeah. But anyways, they will not ask you to draw the one dimension one. Instead, they will always ask you to draw the two dimension one. Okay, so you actually need to draw two light rays, which by right is supposed to look something like this. By right, you're supposed to draw one light ray that hits the mirror, and then there's a normal here. It will bounce off because law of reflection states that this incident angle should be the same as your refracted angle, right? And then you're supposed to draw the second light ray, which also hits the surface, which bounces off. Yeah, the same angle, right? So this is your I and this is your R, right? Then you're supposed to draw the virtual light rays, guys. You're supposed to draw the virtual light rays down and then the virtual light rays up here. Wherever that line intersects, that is supposed to be your point of interest of the anti-Hitler, basically, right? Sorry? What do you mean any point? Like it could be this point or this point or this point. Yeah, it could be any point, but let's just say right now I'm saying this is the point of interest. If let's say they ask you to draw something like here, then obviously you have to draw another light ray, bounce, and then blah, 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 then blah, 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 and this will be a point of interest, right? But usually they won't ask you to layer it or not. They'll usually just give you one point of interest only, which in this case here, I give an example, is the hand there. Okay. Now I want you to understand this, guys. This is very important, which always comes out in the exam. Listen up. First and foremost, they will most likely ask you what's the characteristics of this image in the mirror. Okay. The standard answer is for sure it is virtual. Okay. Now, why is it virtual? This is definitely not because it's virtual reality, guys. The reason why it's virtual is because the real light here, right, actually bounces off the mirror. If you think about it, the real light is not going to enter the mirror, right? Right. It will bounce off. So it only seems as though that the light is going into the mirror, right? So this is what we call the virtual light. All these dotted lines here, which are not real light, is known as virtual light. Whenever virtual light intersects and forms an image, this image here will be considered as virtual. Is number one. Okay. The second thing is it will be something we call laterally inverted. Okay, what does laterally inverted mean? Basically, if you think about inverted, is upside down, right? Laterally inverted is left side right only, which makes sense, right? Because this guy here is actually raising his right hand and this guy here is raising his left hand, right? Right, this is what we call laterally inverted. Left side becomes right, is known as laterally inverted. Okay. Now there's a much easier way to cheat in your exams when you're drawing this, because most of the time what happens is, right, some students, they'll measure this angle wrong, and then this angle will be wrong, and then this angle will be wrong, and then this angle will be wrong, and then at the end of the day, right, the hand is actually somewhere around here. And oops. Yeah. Somewhere around here. Yeah, the hand. Anyways, they'll still draw something like this. So it's actually much easier to cheat in these kind of questions, okay? So what do? So let's say, for example, okay, right now this is the mirror. Okay, and then this is a light bulb. And they'll ask you to, it's hung by a string. His child is excited already. I didn't know that kind of thing turns your knobs. Anyways, let's imagine this is a light bulb hanging on top of a ceiling, and the ceiling is full of mirrors. Let's just say that. Right. The best way to cheat in this kind of exams, in this kind of questions, right, is to literally take your ruler, measure how long this thing is. Right. Let's say, for example, it's 5 cm. Okay. You put your ruler exactly behind the mirror, which is going to be somewhere around 5 cm here, and you straight away draw the image first. Right. Because, guys, if you think about it, the image will always be formed exactly opposite of your mirror, right? Right. So I mean, exactly opposite of your object. Once you have this already, right, then it's much easier to draw the light rays already. Because just now I said, you're going to draw this, then bounce that, then draw this, then bounce that, then dot all the way, right? Now no need already. What you do is, right, because you've already located where the image is, right, all you need to do is literally, right, let's say, for example, this is the point of interest. Draw one line here, dot it back into the point of interest here. draw one line here, dot it back to the point of interest here, and then like you pretend that you actually did the work lah, right? And you only do the others. For sure, this one will be correct one. Like you do this, you have a higher possibility of getting it right than wrong, compared to you do it step by step, which is a do this, then measure this angle, then reflect, then draw this, then measure this angle, then reflect. Sometimes I've seen this more often than not. Usually like this, the students are here will be like what 1 degree off, and then here will be like 2 degrees off, then the whole thing is right. You just do the cheating way, right? Much easier. For sure we'll get it correct. Right? In fact, later there will be a question which is exactly like this, and I'll see how you guys do it. Okay, remember, the whole idea is just to remember that the image will always be produced exactly opposite of the mirror. Then from there onwards, you can cheat your way already. Okay, everyone? Yes, anyone's got any questions? Good, 100% absorption rate. That's what I like. Okay, if you look at this question here, this part here is basically all the things that I've mentioned. This one here, you don't have to draw. This one is like literally drawing 6 light rays already. You don't have to do that. You just need 2 of it. Maybe you draw like this one, and then this one here, then you reflect, and then you draw the virtual light rays, blah, 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 wherever the line meets, that's where the image is much easier. Okay, so we look at the first statement. Image formed from a plane mirror is always virtual / what was the term I said? Very good. Laterally inverted. Write that down. Right now. Okay, and then the second one, not so important. An image is said to be virtual when the light does not actually pass through the location. It only appears to an observer as though the light is coming from the location. So, like I said, these all are not real light. These are the real light. Right, these are the real light. Everything else in the mirror is just virtual light. Okay, and law of reflection is the same here as well. Law angle of incidence is angle of reflection. The incident ray, the reflected ray, and the normal all lie on the same plane. They will be one side of the mirror. They will never be on the other side of the mirror. Okay. Yeah, nothing much here. This one is important also. This one, a lot of students always cannot draw this one, so you better pay full attention right now. And in fact, you'll be asked to draw this a lot when you practice your past year papers. Guys, everyone here that has been swimming before, right? You'll notice that when you look into the swimming pool, it always seems as though it's much more shallow than it is deep, right? Why is it always much more shallow than it is deep? It's because I tell you this, everyday life, we see light and we know that it's supposed to travel in a straight line. But when we look at light at different mediums, they actually do not travel in a straight line. You know, like last few weeks ago, I've talked about the straw, the bending of the straw, right? Like you have a straw here and then you have this thing here, right? The reason why it bends here is because there is a change in the speed of light, right? Here, there is like 3 × 10⁸ meters per second. Here is probably a little bit slower, which is 2 × 10⁸ meters per second here. Okay. And because there is a change in speed of the light, which I've mentioned 1,000 times, refraction occurs. So if you think about it, if today I'm standing on top of a swimming pool, right? Let's say this is me right now. This is you standing on top of a swimming pool. What happens is, right, if we draw it in terms of 1D, when we look into the swimming pool, right, what happens is because the light actually bends, you know, we assume that light will go straight, but what happens is the light actually bended like this. It was supposed to go straight, right, but the light bended like this, okay? And because this is where we see where the real light is, what happens is we assume that the light did not bend, we assume that the light was straight, and this is where we think the surface is when we look on top of the surface. Okay, that's why it always seems as though it's much more shallow than it is. In fact, when I was very young, I looked into this swimming pool and I saw the sign which clearly stated 10 meters. And I'm like, no way this is 10 meters, right? Looks kind of shallow. And when I jumped in, holy shit, it was 5 times my height at the swimming pool. It was literally 5 times my height. I tried to dive, and I couldn't reach the ground. It was too damn deep already. Which makes me wonder, why was there such a deep swimming pool?
You almost down.
No, I mean, I tried to reach the ground, but when you go very deep down, the pressure in your ear hurts like crazy, and because of once again the formula. What's the formula for pressure in liquid again? Yeah, low GH. Right, because the height of the water is damn high, and the pressure is damn high also, and it presses against your ear. It hurt quite a bit, but Gilbert managed to dive all the way down and touch the ground, and he couldn't stop boosting the other because I couldn't do it. Now some sibling rivalry once again.
Or the other one for that one.
But
Oh, all the time, man. The last one was like, I think 2-3 years ago, and it was over the dumbest reason. We went over to my aunt's place, and then I said I want to sleep on this bed, and I said no, I want to sleep on this bed. Then I thought about it. What socks?
oh, he hasn't seen the story.
What fuck?
You can
Oh, basically.
and
Of the monks,
Ew, that's disgusting. Ew. No, we were. That fight was not for fun anymore. Right? That fight was like, fuck, I want to spit. No, I want to spit.
I wrote it down.
Yeah, 3 years ago. So it's like the sibling rivalry never dies. It just takes one spark and start fighting again. Anyways, it was really dumb. I also don't know why. Okay, but anyways, yeah, this is the reason why. But of course, in your exam, they will never ask you to draw the 1D version. They will always ask you to draw the 2D version instead, right? And if you're asked to draw the 2D version, you gotta imagine like this guy is crooked eye like fuck, like his eyes is here, right? So that this is like some tadpole guy already, right? Like literally with a tail, then it's tadpole. Anyways, let's imagine this guy's cock eye like crazy, right? So what happens is you have to draw the light rays on, and when you draw the light rays, your idea is that, okay, let's imagine today I'm looking at a fish, like for some god forsaken reason, there's a fish in your swimming pool. But most likely will die due to the chlorine, right? Wait a minute. Will it die? Anyone rear fish at home?
Yeah.
Will it die?
So,
You don't think so? Sure. Okay, but anyways, yeah, this is what's gonna happen, guys. Let's imagine today you look at the light rays, right? Your idea is that your fish should be somewhere, your image of the fish should be somewhere around here, right? Right. This. Alright, pay attention, right? Bloody hell, later you're not gonna know how to draw this again. Don't play with your phone, okay? Put your phone away. First and foremost, you're gonna draw your light rays, gonna go somewhere like this, okay? Like the 2 eyes, right? It's gonna oh god, it's gonna look like shit. Anyways,
super bad.
the whole idea is you want the light rays to converge at one point of the fish, guys. So what you do is once it reaches the water barrier here, it will bend a little bit, right? It will bend a little bit, and then it will bend a little bit, and it will get something like this. But this is what you actually see. But in your brain, because you always perceive light to travel in a straight line, right? What happens is your brain is going to think that the light rays went straight like this, and eventually they'll intersect somewhere along this line here, right? And that is the reason why the fish, the image of the fish, at least this is the image and this is the object. Wow, some reason it become bigger also. But anyways, that's not the matter, right? The image of the fish will always be slightly above where you have it. Now, the key to drawing this are very important. Pay attention to this. The key to drawing this, right, is you need to know that ultimately you should have a triangle, like not a triangle, like a spear kind of converging light ray kind of thing, right? That will end somewhere here, right? So when you draw it, you actually have to you have to converge the light rays on the water. It's going to be quite hard to draw it like for the first few times. Your idea is that your light rays should be converging somewhere in the image, right? You should have the rough idea that oh, right now I want the light rays to converge somewhere in the image, so that's why I should draw something like this to converge, then bend it, converge here, then only a dot, 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 and dot, 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 converge here. Okay, this is very important. But once again, there is an easier way to cheat in these kind of questions, right? Because most of the time the students find this very hard, right? So I've devised an idea to cheat for you guys already. So usually they'll say like, okay, this is your eye. Now this is not a cock eye anymore. It's like literally just one eye, right? Then like this is the swimming pool. Okay. And I say that, okay, your damn fish is here right now. Okay, then they ask you to locate where the image of the fish is. The first thing you want to do is you want to have the idea that the image of the fish will be slightly above, right? So the best way to do is straight away you cheat. Okay, you cheat. And then what you do is you draw damn fish first. Once you have this fish already, right? That'll be much easier already. Why? Because once you have this fish, right, you can literally draw like straight lines here. Right? It'll be much easier to do like this, right? And from here, okay, actually. And from here, yeah, you converge like this.
How do you actually do it?
Huh? But I just told you just now like this. It's going to draw this light ray, bend it, then continue this straight line here, then continue this straight line here. It's not. It's when you draw it later, you'll know. It's like if you try to do it the normal way, it's actually much harder. You need to have some form of understanding and how to do it. But if you do it like this, right, you're literally just converging it to the top of the fish, and then after that only you do this. It'll be much easier. Yeah, you do need to draw the dotted lines, but I don't have the option to do the dotted lines here. Like this straight line here is supposed to be dotted because it's not real. The real light bent already. The virtual light is going into this position here. Yeah, I mean, but don't worry, later you'll see some questions which you'll be expected to draw. No, it's a perception. The real fish is the green color one, but we perceive light to travel in a straight line. That's why it appears like this. Like the reason why the bottom of the swimming pool it always seems more shallow is because it's not actually more shallow. It's just that we think the light travels straight. That's why we assume that the fish is here. And then you see like all the kung fu shows, right? They stand on top of the river, then they grab the fish, right? It's quite impossible. They must have trained their mind to look at the fish here and then grab somewhere else. Only then can they grab it. Because if you just look at the fish in the water, right, no matter how fast your damn kung fu hands is, like the Bruce Lee kind of shit, you can't catch it based on your sight itself. You must look at the fish here and you must aim somewhere else to grab the fish. That's most likely what's happening now in their head. Of course, it's kung fu. What? What?
You say set the pool on fire.
Set the pool on fire?
What?
What? What? So what? You set the pool on fire, so you pour like gasoline onto the surface of the water? Huh? San Francisco what?
And friends do.
What the hell is that? Nice. Man, you kids are watching too much TikTok nowadays, huh? With all these fancy things. That's good. I want to highlight one thing, guys, for those who have like been frantically scrolling TikTok, secretly or not. It's fun to do it on your free time, right? I think TikTok is actually full of too much shit and fake facts already. And then you know what's worse? Because right, these people, these assholes on TikTok, right, they'll say like it's a fact, you know, like for example, they say something like, I don't know, I heard
Jamie Foxx guys.
yeah, and then they'll say like, oh my god, guys, you know, they'll record themselves looking like really serious, and then they'll put like some fake statistics that obviously was plucked from their ass, right? Then they'll say, oh guys, you know, if you do this one exercise every day, your memory will be boosted by 3 times. And then studies from the ass, right? Shows that, oh, if you do this one exercise, it will help boost your longevity or something dumb like that. I must say, guys, it's really fun to watch if you got nothing to do, right? But try to limit your time off TikTok. It's definitely more cancer than it should be. Okay, anyways, back to this here, guys. So yeah, I would highly recommend that you have this image in your head. If you have this image in your head, it's much easier to cheat in the exam because ultimately you just need to know that the fish is slightly above. The image of the fish is slightly above. When you have this, you just draw. Sorry? It could be. Yeah, it'll be slightly to the left out because if you think about it, it's not exactly above it. It'll be slightly to the left out. It will be slightly to the left. Okay? Good. Yeah. Refraction occurs when light travels from one medium to another. When we say the word medium, guys, we're basically talking about different density mediums. For example, air is one medium, water is one medium, glass is one more medium, plastic is one more medium. Everyone, I don't want to see you guys playing with your phones in my class. It gets me a little. That's worse, right? You're listening to music while I'm talking. Oh, from TikTok, is it? No, don't do that. Don't play with your damn phones in my class. One day I'll just blow at you, and then you'll be like, oh shit, this guy's anger issues. But yes, don't play with your damn phones.
Hold on.
Family Guy Go what? Put that phones away. Hey, put your damn phones away right now. Okay, so anyways, pay attention to this. This is going to be the next one that's going to build you up to the next calculation questions. Guys, based on the way that the light enters different mediums, it will either refract or not. Okay, the most common one is if the light enters the glass block at a 90 degrees. Guys, if you see here, it's obviously 90 degrees, right? Light actually doesn't go through refraction. Meaning to say it will go directly straight through. Okay, it doesn't bend at all. But any other angle beside 90 degrees, it will either bend towards or away from the normal. Okay, now if you think about it, once again, this one here plays with the speed of light again. If you think about it, at air, right, the speed of light is the fastest, right? But when it goes into this glass block here, what happens is because there is more medium inside, that it is more dense, basically, right? So what happens is the speed of light slows down. If the speed of light slows down by right, the speed of light, the light should have been like this, right? Should have been one straight line, right? And because it slows down, it actually lags behind. So this is what we call bending towards the normal. This new light here has bended towards the normal. Okay, and this is something you must know. When the question asks you something like, okay, when it goes from less dense to more dense, where will it bend? The answer is it will bend closer towards the normal. And the exact opposite will be true also, guys. If let's say I go from more dense, which is in this case the glass, going into less dense, which in this case is going to be the air, by right, the light should have been one straight line here, right? And because it's sped up, speed up, whatever, I speed up, right? Right, speed up. It's speed up, right? So what happens is the light actually bends away from the normal, guys. Right? You must know this. Now, one more thing I do want to highlight is that later on, this will be related to your calculation, which a lot of students always get this wrong. I will beat you if you do this wrong. Oh boy. Oh boy. Sounds fun. Okay, so let's imagine today this is a glass block, all right, and I have light traveling into here. Okay, let's assume that this is the normal initially. When it goes from less dense to more dense, it will bend towards the normal, right? So it will bend something like this, right? Then at this scenario here, it goes from more dense to less dense, so obviously it's going to bend away from the normal, right? Now, pay attention to this. This is important, which is going to be your calculation later on. Do you know that this angle, which is known as the incident angle, is also this angle here, which is also the incident angle? Because if you think about it, right, this is speed of light, right? This is speed of light in the medium, right? And here is once again the speed of light, right? If these two are the same speed, then by right, this angle and this angle should be the same. This is important, pay attention, guys, right? Meaning to say the z rule applies here in mathematics also. This angle, which is the refracted angle, will also be this angle, which is the refracted angle here, right? Sorry?
Okay, that's the parallel line.
Yeah, because like, you know, like the z rule, right? Like as long as they're parallel, then it's going to be the same, right? This is exactly what you learn in mathematics. Now, next thing that I'm going to teach you is basically going to be something known as the refractive index. N equals to sine I over sine R. I think some of you guys learned this in school already, right? Do you know that regardless of whatever the question gives you, pay attention to this. This is like the most important part. This one here will always be the angle in the area. And this one here will always be the angle in the glass or water or medium or whatever it is. Okay, this one is very, very important. And so how will the IGCSE questions trick you guys, right? They'll give you something like this. Okay, right now, this is the glass block. Okay, and then they'll even say this, they are damn, and they'll say something like, okay, this is the incident ray. They'll say, this is the incident ray. Okay. And then they'll say that obviously it will be refracted, right? And this will be the refracted one. Okay. They'll say something like, okay, if let's say the glass block has a refractive index of 1.5, and they'll even say this, they'll say that this is the incident angle, right? They'll say that this incident angle is, let's just say 25 degrees. How much is the refracted angle? Which you're supposed to use the formula, right? You're supposed to use the N equals to sine I over sine R formula. Then, yeah, you're not supposed to put the I in the I. You're not supposed to put the R in the R. Because if you think about it, right, this is just half of the story, right? This is no way in hell going to be the incident angle, because if you think about it, they are just showing you this bottom half of it, right? They're just showing you this bottom half of it, which a lot of students will always forget. Then you know what they'll do to me? They'll say something like, 1.5 equals to sine 25 over sine R. Okay? And for sure, without any calculation, I know for a fact that their R will be less than 25. Let's say they find the R to be 17 degrees. Automatically, this is wrong already, right? How can this be 17 degrees? If you think about it. It should bend away from the normal. If anything, it should be bigger than 25 degrees. Right? You understand what I'm talking about? Regardless of what the question give you, whatever they will call this incident angle, incident rate, or whatever, blah, 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 it is, right? When you do this calculation here, this I must be the one in the air, which in reality is this one. This R must be the one in the medium, which in reality is this one here. Only then can you get a refracted angle more than 25 degrees. Any other way, your calculation will be wrong. Do you guys understand what I'm talking about? This is very important. And this will very well be the one that differentiates you guys from the lower threshold, guys. Because most likely, more often than not, 60 to 70% of them, they're going to get this question wrong if this comes out in the exam. And if you can get this question correct, you automatically score a little bit higher in terms of the threshold. That's why I say this is very important, because most of the students will get this wrong one. Okay. Later there will be a question, and if I see you do it wrongly, I'll be you. Okay, guys, copy everything down from here. Oh, by the way, this is less dense, not dense. Copy everything from here, real quick. Oh, is there nothing to copy? Yeah. Okay. Let me just get my water real quick. Okay. Well, the first one, how do you play the conclusion player?
You ever thought of getting into food with that?
How do you have the,
It's like a big flaming fire, imagine that, and I got a shit with,
so, but then we leave the schedule really long. And then in fact,
and then you have to.
do it. It's kind of stupid enough.
Oh, you look like real food.
But one day if I get to enough farms, go for it. Yes.
Even your brother could be like those, your brother could get this and that, so people are back, yeah. But that's my mind, so, yeah, and it's. You know, it's
Where face big. How big is real as golden and. Yeah, the other one, right? Are you one? Oh, I was just thinking players, like I said, if you that was us. What? That was. Friends.
What's your reference?
Oh, wow.
Oh, shit.
You bad.
So what was like the next stuff? Like having a body.
Old Steve.
You guys fighting that one?
Yeah, almost two is a blue pot.
No, I think I did something. No, I something. But other stories of like people with the power that like lives inside the inhibitor. Yeah, like it doesn't kill that way, no, they really pursue that.
It's like a story.
Yeah.
The story. Yes, in all the actually do that. Yeah. Yeah, that's why they're the top of the food chain.
Why did you devour?
I didn't have it in me.
Wait.
Okay, the last part we'll talk about here is, guys, why does light bend when passing through different mediums? Because there is a change in the speed of light. I keep saying this over and over again. You must understand by now that refraction is due to the change in speed of light. Right? The angle of refraction can be calculated using the refractive index here. Refractive index by definition is speed of light in a medium divided by the speed of light. Sorry, speed of light in vacuum divided by speed of light in medium. The higher the refractive index, the more the bending of the light, as you can see from this here.
Only refractive index is fixed, right? Although different time process is a refractive index.
Yeah. Guys, in terms of the refractive index, how is it applicable in real life scenario, guys? First and foremost, I want to let you know that if you ever calculate your refractive index smaller than 1, you are wrong already. Don't need to continue. Why? Because vacuum is the baseline for refractive index, which has literally no medium inside, like no anything inside. Refractive index of vacuum is already 1 already. Anything more than that is going to be higher than 1, and of course, glass has the highest refractive index. Diamond has the highest refractive index. It's actually going to bend more and more and more and more. Right. Now, in terms of why diamond has the highest refractive index, is also the reason why when you buy a real diamond, it seems as though that it shines from within. You know, like a lot of cartoon when they open the diamond, it seems like it's like glowing, right? You know, that's not what really happens. The fact is that, right, if you compare a real diamond with a pasar malam diamond now, right? So this is a real diamond, which is nicely blue, and then this is a pasar malam diamond, which is for no racism purposes.
There was actually nothing surrounding race.
It's brown in color. Shut up, lah, you always try to pull this on me now. I'm just saying it before, then you say no. Okay, but anyways, right. So what happens is, right, because diamonds have very high refractive index, what happens is, right, when light enters the medium, it actually goes through much easier total internal reflection, right? And because it keeps going through total internal reflection, when it comes out, it seems as though like the diamond itself is shining, right? It's the same reason like why you see all these lights, right? On top of it, there's a layer of reflection. And why is because they're trying to reflect the light into larger surface area, so it seems like it's brighter. If today I remove all these like mirror panels behind the light bulb, this room for sure becomes darker, right? Because there's no reflection, right? But in this diamond, it's the same scenario, just that it doesn't use reflection, it uses total internal reflection. That's why it seems more bright. But if you look at the Pasar Malam diamonds, right, they always look a little bit more dull. Is because the light, as soon as it goes in, right, maybe it will bounce once or even twice, but it starts coming out already. In terms of the intensity of the light here versus the intensity of the light here, you can see as though that the diamond is much brighter here. Yes.
How do you know how many times it bounces?
I don't know. I'm just saying only. But I know for a fact that it definitely bounces more than this one. Okay, this one will definitely bounce more than this one because this one has a higher refractive index because it's diamond, right? Okay, so this is the application of refractive index.
Because refractive index is fine, like the angle that we can build or like how we make the box.
It will define what's the angle that it tilts. In fact, it will tell you what angle is supposed to bounce. But that's a calculation for next week really. But anyways, guys, I just want you to copy this last thing down and then do this as homework because most likely we don't have enough time. You're supposed to use n equals to sine I over sine r. There's no units for refractive index because if you think about it, it will be like angle divided by angle, which will cancel off each other, or it will be meters per second cancelled off by meters per second. So there's no units for refractive index. What? It's the
I think that
it was it.
Wow. Wait. Oh, wait.
Oh, first question, there's missing information. You should be given the refractive index. Sorry? What did you? Yeah. First question, there was missing information. N equals 1.5. Yeah, sine I will always be the one to pair. Write this down, my guys. Your sine I. This one here should always be the one in pair. No matter I repeat, matter what the question says to you, the priority is that it should be the one in pair.
Smooth table, right? My books are here, and then right where I did my calculator. And other kind of the box behind, I started to see it. Why did I go to that? Because I was going to another class and or something outside, it's not in the rush. But I did that with my box. Then it was sense of offer without being a calculator. It's like, okay, later, they get later, then I was going to all it you decide. It's still.
But it's the
Right. You're not that.
Yeah.
It's gone. Speed up that.
Yeah, in fact, when I was very young, I always wanted to be Batman.
Why?
Because if you think about it, in the only superhero without superpowers,
Because the other superhero, like,
is big sure. Yes, and he has lots of money. What not then not like
you don't compare.
Asian pattern after yellow see
The flash.
hey I'm not Facebook see
You know. It's
if I don't see
second shoot. Thanks for the attention.
weeks beforehand.
It's the gas.
What's that? Finance. What? Finance. And then,
We can't, right,
Google.
yes, yes.
but this.
That's a great degree coming up. 18 and went down.
There's it's not very different, but it's still English 7.
Okay, you guys want to have a meeting.
Oh, well, you got it. Okay.
Hey, yeah, we all have a meeting. Hi. Yeah. There's someone.
Yeah.
It's so big that you could be without any issue.
How long is it be back I didn't say.
Oh, by the way, if you just one thing down for the speed of light in vacuum, you should be given constant number. It should be 3 times 10 to the power of 8 meters per second. Write it down on your calculation, on your formula. This is a constant number which you are expected to know is like gravity. 3 times 10 to the power of 8 meters per second for speed of light in vacuum.
3 10 to the power of 8 meters per second. Other man.
What's not?
That is same air and vacuum same.
And
Oh, this one was nice. Oh, that's a big question. What?
so what do we do when value fear? Something that is, but
What you do is this is your V, right? I mean, with your V, you have C, so you can next. And with your refraction index, you use this refraction violence. The factors are see like it's not some the 3 point something from the others. It doesn't the big one was like something.
what do you do when see?
Oh, basically, I can use something I'm thinking. I'm the picture of various of when people know. Yeah, but it's this. Oh shit! Hey guys, by Justin's movement here, I realized that this should be a medium. That's why there was a confusion. Yes, change it also, guys. The final question, which is on the next page.
Oh, so we give something that equals the speed. Your life will back. Like.
If you want to think about it, yeah, because this is n and this is also n, right? You could equate them together and say that sine I over sine R is equals to C over V, yeah. You could equate them together.
C over sine or.
C over sine R, no, of course not. You could bring this over and bring this over lah. Then you get like V sine I equals to C sine R lah. You could do this but it's not interchangeable because if you think about it, if you do this over this, right, it'll be meters per second divided by angle, right? But refractive index has no units. Okay, guys. Anyways, I'm gonna stop class here today, guys. You can go back home and finish it if you're not done, but I think most of you guys are already done already. Right. We'll continue this next week. Then after that, we'll do some exercises next week, and then after that, we'll be preparing you guys for the exam. So okay. All right, guys. I'll see you all next week.
I think you